Today I'm going to be factoring completely, and this is for anybody who doesn't understand how to factor completely or doesn't know how to factor completely and wants to be ahead, or maybe you're just doing factoring and you're not factoring completely out, or you don't know either. I'll explain both, but yeah, so let's do it. And before we start, I just want to give a quick note. Since we're doing math or arithmetic, and normally there's normally four things you need in math. Or normally the four things I like to have in math is I have my mind, I have algebra, I have a lot of time, especially when you're in the learning phase, and the last one in the acronym of math that you need, it's probably the most important one and it'll keep you going. It's hummus. See, hummus is a spread. And if you have a spoon with the spread, it's pretty good. So anyway, the first question is, let's see, okay. That's in frame? Yeah, it's in frame. Is 3x squared plus 12x plus 12. Plus 12. Now what you want to do is you want to find the greatest common factor of 3x x squared, 12x, and 12. Now because you have a variable in it, it makes it more confusing because of course there's algebra. So what do? If you forget about it and you just look at it as 3, 12, and 12, well, we know that the greatest common factor of 3, 12, and 12 is 3. 3 goes into 3 once, and 3 goes into 12 4 times. When you add in the x, it doesn't do anything for this problem because not all the terms have an x in them. 3x squared has an x in it, 12x has an x in it, but 12 doesn't. So, because 12 doesn't, you can't factor out a GCF of x. So, because you could only factor out a GCF of 3, you take out the 3. Let's see if you could, that's in frame? Yeah, that's in frame. So, you take out the 3, you divide everything by 3, and now you have x squared plus 12x plus 12. So now you have to factor this like you would normally factor it. How would you factor it? So what you have to do is, we could do it the textbook definition, calling them A, B, and C. That'll help you kind of, it'll make quadratics more understandable because that's the quadratic, that's the way that quadratics are written, the standard form. But we're not doing quadratics. So just know that quadratics are polynomials that are equal to 0. Well, no, typically trinomials. But what we are doing is, what you would do is you take the last term and you multiply it by the coefficient or the number in front of the first term, right? So now 12, oh shoot, I didn't divide, my bad. This would be 4x, and this would be plus 4. You would take the 4 and the 1 and you multiply them together and you get 4. Now what factors of 4 add up to 4? Now the key is that they have to add up to 4. They can't multiply to 4. So you might think, oh, 1 and 4, but those add up to 5. The ones that you want to do is 2 times 2, because that equals that, because 2 times 2 is 4 and 2 plus 2 is 4. So because now we know what that is, we can rewrite the equation as x squared plus 2x plus 2x plus 4 And then what we do is we look at it like they are two separate expressions. And so it's x squared plus 2x, and then 2x plus 4. And we see what's the greatest common factor of each expression. So x is the greatest common factor. It goes into both of them. So you would do, take out an x, and you take out an x, and you have x plus 2. And then over here, you can't take out an x because there's no x near the 4. So you would do 2, then x plus 2. If you do it right, you'll notice that these two expressions in the parentheses are the same thing. And so now that they're the same thing, let me move that down a little bit. Now that they're the same thing, you do x plus 2 since they're the same, and then you take a look at what's remaining. You have this thing and this thing. And so because it's an x and a positive 2, it's x plus 2. Now we have to go back to originally when we had this equation, and the 3 comes right here. So 3x plus 2, and then x plus 2. Or, because it's the same thing twice, we could say 3 times x plus 2 squared. And so that, from what do we have? From 3x squared plus 12x plus 12, we simplify it down to 3x plus 2 squared. Okay, so the next interesting one that I found is 9x cubed. See, is this one page? Yes, it's one page. 9x cubed minus 9x. So because it's only two terms, because it's a binomial and not a trinomial, it looks different. You can't factor it. You can't do the GCF thing. You can't factor. You can't do, oh, this is the last term, this is the first term. You can't do that because there has to be 3 terms. So what you would do is 9x cubed minus 9. Because they both have an x in them, we know we can take out an x. And because they both have a 9 in them, you can take out a 9. Now you're saying, oh, but this is a negative 9. Surely they are not equal. Surely you cannot take out a 9. But negative 9 is equal to 9 times negative 1. So you can take out a 9. And in fact, when you do so, you get times x squared, and then minus 1. So now you have minus 1. Well, what do? Well, the key thing is you don't want it in factoring completely is you don't want to have a parentheses that inside of it has an exponent at all. So you could say, oh, well, all numbers are raised to a power of 1. So I'll say a visible exponent. So 9x times x squared minus 1. Now what do you do with the x squared minus 1? Well, there's this neat trick. Whenever you see a minus 1 and a thing squared, it's always going to be this minus this, whatever this number ends up to be. So if it was x squared minus, let's see, what's a perfect square? X squared minus 4, you could always, it's going to be x squared minus 2, x squared plus 2. If it's x squared minus 1, it's going to be x minus 1, x plus 1. I think I messed up with the x squared minus 4 thing. If it's x squared minus 4, it's going to be x it's going to be x minus 2x plus 2, because it's the square root of both of them, and you make one positive and one negative. If it's positive, it's a bigger trouble, because you can't just do that. You have to factor it out. You would have to FOIL it. When you FOIL x minus 1, x plus 1, the middle terms cancel, and that's why they give, that's why they only do x squared minus 1. But when you have a plus sign, the middle terms don't cancel, so you know that there's going to be 3 terms, which means it's going to be a trinomial. So just so you know, because it's an x squared minus 1, we could use the trick, and you get x minus 1, x plus 1, times 9x. And that's how you factor 9x cubed minus 9x. In the pursuit of saving paper, because we don't hate trees, we'll use the same page. And this is the last question I'm going to actually... Wait, no, 2 more questions I'll do with you. That one doesn't seem too bad. It seems like a repeat. Yeah, why not? So, I'm going to do 2 more questions. The second question I'm going to give you, we've done one similar to it. So you don't have to do it if you want to be challenged. You could watch me do it in this video. But the first one, I would definitely recommend you watch through it, because it is something different from the previous ones we've seen. The one we get is, let's see, 6a squared minus 6a to the 4th. So now, why is this one trickier? Well, it has exponents, and both terms have exponents, and this one is squared, and this one's to the 4th. Normally, the first one's to the 4th is to the greater power, but it's not. So, what are we going to do, you say? Well, we know that a goes into both of them. We know that 6 goes into both of them. So, we'll take out 6a. 6a. What happens? 6 divided by 6 gives you 1. A squared divided by a gives you a. Negative 6 divided by 6 gives you negative 1. A to the 4th divided by a gives you a cubed. Now, actually, when going through it, you could have actually done more. Because it's an a squared, and this is an a to the 4th, you could say that a to the 4th is comprised of 2 a squareds. Basically, what that means is you could take out an a squared as well. And so that'll help with simplifying, so let's do that instead. So 6a squared minus 6a to the 4th, 6a squared times 1 gives you 6a squared. And then negative 6 divided by 6 gives you negative 1. And then a to the 4th minus a squared, a to the 4th divided by a squared is equal to a to the 4 minus 2, which is a to the 2nd, which gives you that. So basically, 6a squared minus 6a to the 4th is equal to 6a squared times 1 minus a squared. Aha! But now you see, we still have an exponent, and we don't want that exponent. So we're going to simplify this even more. 1 minus a squared is equal to 1 minus a times 1 plus a if we use that same method that we used before, where we know that we take the square root of and the square root of this one, and you get them. So, all in all, when you factor it out completely, this is the most expanded version and the most simplified version of 6a squared minus 6a to the fourth. Now these two, well, I'm going to give you one more. With the skills used in the one I just gave you, you could probably solve it. If you were a bit iffy about that, I'm going to do one similar to it and see if you could get it. 9x squared plus 18xy plus 9y squared. So we already know that we could try to take out a variable. So let's try x. Well, sure, we could take it out of this, we could take it out of this, but we can't take it out of this one. What about y? We could take it out of this, we could take it out of this, but we can't take it out of that one. So the only thing we can take out at this moment would be the 9. Take out the 9. We now have x squared. We have plus 2xy, because 9 divided by 18 gives you 2. And then you have plus y squared. There are no more GCFs in this. So what do? You factor it. Y squared, the coefficient of 1, times the coefficient of 1 gives you 1. Okay, so we have 1. What are the factors of 1? 1 and 1. 1 times 1 equals 1. 1 plus 1 equals 2. Bam. So what does this mean? We could rewrite it as x squared plus xy plus xy plus y squared. And now we could find the GCF of these things, because when we split it in half, you could take the x from this side and you could take the y from this side. If you take out an x, you get x times x gives you x squared. X times y gives you xy. Now, what can we do with this? Well, y. Y times x gives you xy. Y times y gives you y squared. As we see, has the same expression inside the parentheses, so we know we've done it correctly. X plus y, x plus y, x plus y. So now we have x plus y times x plus y. We bring down the 9, and we have 9x plus y, or 9x plus y squared. And that's all the examples I'm going to give you and I'm going to tell you for now. The last example I'm going to give you is one for you to try on your own. and the answer is going to be in the link in the description. But I highly recommend that you try to do this one on your own and then you check to see the answer. That way you get a good feeling if you get it right, and if you don't, you find what you're struggling on. So the fun one is x squared times x plus 2 minus 9 x plus 2.